Hey, what's up, guys? This is Chung. So today we're going to talk about this LeetCode problem 437, path sum 3. This one is labeled as easy, but to me it should be more like a medium problem. Okay, so let's see. Let's get right into it. So what does this problem say here? So you're given a binary tree here and a target sum here. You're supposed to return the number of the subpath whose sum is the same as this target sum. So for example here, for this binary tree, notice that the subpath can start from anywhere. It doesn't have to start from the root here. For example, this one there are like three subpaths. First one is this. First one is this like 5 5, 3, and then the second one is this one, right? And then the third one is this one, right? So how do we do it, right? So I think the first way will be the brute force. Basically, when we traverse this tree starting from root, every time when we see another node, we'll just use the same sum, and we'll try to use that node as a root node to see if there's any subpath starting from that root node that will have this that can have this can have the sum equals to this the target sum, right? I think that time complexity will be like will be n square, yeah, because we'll be for each node we'll traversing the rest of the tree, right? So it's like roughly n square time complexity. And so how can we do better, right? A better way will be we'll be maintaining a dictionary. So for the dictionary, we'll be maintaining a sum, a running sum in that dictionary, right? So every time when we see a node, we just keep recording the running sum of the current node, and along with the running sum, we'll also be recording. So basically, the key of the dictionary will be the running sum, and the value will be the frequency. Basically, how many times that running sum had appeared before. So how will that running sum and the frequency help us, right? So remember here, so okay, so I think one concept you guys may already know is that, so to calculate this like this subpath of the sum of the subpath, let's say for example this 2 and 5 here, right? So the sum of this path is 7, right? So how can we get this 7 from running sum, right? It will be basically the running sum of 2 is what? 17, right? And the running sum of this 10 of this like root node is 10, right? So this running sum minus the previous one mining running sum will be 7. Basically 17 minus 10 will be 7. Then that's how we use this running sum to get the subpath. Okay, then how about this frequency, right? I mean, so every time when we have a running sum, right, we'll be comparing, and then we'll subtract the running sum with this 8 here, with this target running sum. Let's say, for example, if there's a 17, right, 17, and then we minus 8, if there's a 9, it equals 9, right? So and then we check this remaining this result here. If this 9 already appeared in our dictionary, if this running sum, if this like the result of this subtraction is inside the dictionary, it means there must be a path uh, before, I mean, starting from this root node, go all the way up, right? There gotta be a path, but we don't know where that path start. But we definitely know there will be a sub path that will have the will have the the sum equals to this target, right? And that's how we use the frequency. Basically, every time when we see a node, when we see this one already existing there, we just use that frequency in already stored in that dictionary as the current dictionary. Because if you see this like running sum twice, right? Let's say we saw this 9 here, and the dictionary in this 9 uh, for this running sum 9, the frequency is 2, right? Then we know we have all the way go all the way up. There are two subpaths that will have the same will have the same uh, same sum equals to this target, right? That's how we use this dictionary. And okay, enough talk. Let's try to code this issue, this problem here. So and okay, so first we'll be creating this helper functions. Basically, we'll do a DFS traverse, right? And then we'll be like a node. And then, like I said, we'll be having a running sum here to traverse the tree, right? We'll be using a pre-order traverse. Basically, the pre-order traverse will go all the way up to the left, right? And then go back here and then go down again, go to the right side. So uh, this is our final result. Will be initialized to 0, and then the running sum, and then will be like a sum count, right? Or you can call it sum frequency, whatever you want. And then we're gonna have a default dictionary int. So the way we're doing this is because we don't want to handle the non-existent key here, right? So basically, what this one does is if there's now the if the key does not exist in the dictionary, it will basically set that key with a value default. With a value default of integer will be 0, which will be 0. And then we'll do like DFS, right? And then the root and the running sum currently is 0, right? And then we just return some return the result. Okay, so what do we do here with DFS? Remember, so I think for always check if not node, right? And then return, right? And then the second one is the next will be we just updating, we're getting the running sum first, running rum, running sum and value, right? Like I said, we check if this new running sum, right, minus the sum is in the dictionary, is in the sum count, right? So what do? We just add the result from the with that frequency of the dictionary, right? And then after this, remember we update this running sum frequency. We added by 1 because we saw this one, right? We saw this running sum. Then we need to update it, increase it by 1. Default sum dot running sum, right? Yeah. So this is how this like default dictionary will come into play. If we don't have the default dictionary here, we'll have to do a if check here. So basically, if this running sum exists in this sum count, if it exists, and then we do this. Otherwise we just assign this one with 1. But with this default dictionary, we can just save a few lines of code here, right? And if that's done, right, we do what? We just keep traversing, right? Because Okay, so I think here, so why we're just using that, we're not +1 because we will leave how many counts, we'll leave this like how many subpaths starting from the current node to this to the previous stored result. Let's say there are two here there are two frequencies here, and we know there are like two subsums, two sub subpaths. We'll have the sum equals to this target here, and then in the end we just update this running sum frequency, and then remember we need to keep doing, right, because we're doing a pre-ordered traverse, so we'll pass this left with the running sum, right? Because we want to keep doing this running sum, and then the right side, right? Are we done? No, of course not. So there are two things we need to add here. First, right? First is the we need to have like a so first once we have the dictionary here, we have to initialize. We have to add 0, the running sum 0 with the number 1. Why? Okay. Why is that? Okay, for example, like let's say we have this tree here. Let's say the sum is equal to 7. Let's say the sum is equal to 7, and we're having this tree here. So obviously this is including the root. This will be a subpath, right? Let's say we don't have this one. Let's say we don't have this line here. What do? We pass the root, and with running sum 0, right? What Okay, yeah. Okay, I'll change this one later. So when we add the root node 10, then the running sum is 10, right? We just keep going, and then when we add -3, uh, the running sum is 7, right? The running sum is 7, and this one it has to be a subtree, right? So we check here, right? We use 7 minus 7 equals to what? Equal to 0, right? Is it inside of the sum count? No, it's not there because we didn't initialize this thing, right? That's why we have to initialize this one because this is for the root node as part of the subpath. If we don't have this root node 0 with 1 here, basically we will be missing all the subpaths starting from the root. Yeah, okay. So that's first thing we need to uh, uh, be careful. And the second one is what? Since, okay, notice here, we'll be going all the way to the left, right? We're going to, let's say, for example, here, 10, let's, like the running sum, right? 15, uh, 10, 15, 18, right? Here will be 21, right? So when we reach here, we'll be adding 21, right? So remember this sub count dictionary will be shared for all the left traverse and the right traverse, right? And so since we're doing the left the pre-order traverse, we'll be reaching this 3 here, right? With the 3 here, we'll be the sub adding the sum of this one to the dictionary will be like so in this case, let's say 10 10 1, right? And then 15 1, and then 3 is 18, right? 18 1, and then when we add here, right? So that will be 21.1, right? That's the dictionary we have, and then this one is done. This all the way is done here, and then we'll be going back here, right? Going back to 3, and then it will go to the right side, right? Now we're processing the 2 here, right? We're processing, sorry, the -2 here. But remember here, so when we're processing -2, we have, okay, notice here, 10, 15, and 18. Those three sums are valid pre-sums for the -2, but 21 is not, right? 21 is for this subtree, for the left subnode, which means if we keep this 21 inside this dictionary, there will, when we calculate when we calculate the right subtree, we will have a incorrect records here because the 21 is not a valid a pre-sum of this -2, right? So what do we do? In that case, we have to do this. We need, once we process everything, because we process the left side first, right? We do what? We do a count running. We need to remove that. Basically, we just reduce the count by 1. Left side, right side is finished, and then we remove. Okay, I think that should do it. Yeah. Since we're assigning the global variables here, we're gonna do a non-local keyword here. Yeah. Cool. Yeah, I think that's pretty much is for this problem. So we just keep some count dictionary every time when we have a new running sum. We just check if there is a like if the current running sum minus sum is inside the sum account, then we know we have a sub path before, right? So we just use that previous frequency to update the result. Then after that, we just updating the sum here. We traverse to the left and the right, right? But remember, once we traverse to the left or right, either one, re we have to remove this one from the one because either the right subtree or the left subtree, the running sum result will not be a valid one on to the other side. So we have to remove one once this one is done. Okay, cool guys. Thank you for watching. All right, thank you. Yeah, bye bye.